Hey guys, this video is going to be about chemical bonds and compounds. We're going to take a look at kind of chemical reactions and balancing equations. Okay, we're going to also take a look at the properties of compounds and how they're different from the properties of the atoms that make those compounds. So we're really just going to kind of look at how atoms are coming together to make new things, because we've learned so far that there's 118 atoms, right? Those are all the different individual ingredients we have that make everything in our universe, right? We learned 92 of those were natural. Last week we learned that there are certain atoms, certain elements that are more common in life. There are certain atoms that are more common on Earth, but all 118 of those arranged in different ways make all the different things around us. And there are so many different things around us, so there must be tons of different ways that they can combine, and there are. So first we're going to look, compounds have different properties from the elements that make them. Okay, and what that means is, like, take for example sodium and chlorine, right? Sodium is highly explosive in water. Okay, so I want you guys to watch this video really quick. This is just a chunk of sodium, which is just a naturally occurring element, and this guy's just going to toss it into some water. Right? So looking at that, sodium is crazy explosive, and chlorine is a chemical that you would put in, like, water to kill bacteria, like a pool. They use it to clean the pool. So those two things on their own are very poisonous to people. You wouldn't want to ingest either of those. But when we put them together, and it happens, we can do it in a factory, or it happens naturally, like there are salt mines, we make table salt. Right? So sodium chloride, NaCl, is just sodium and chlorine combined, and that makes table salt. And we can put table salt in water and eat it, and it's totally fine. So the properties of table salt are completely different than the properties of the two individual elements that make them, right? So what I'm trying to say is that sodium is nothing like salt. Chlorine is nothing like salt, but they're the ingredients that make salt, right? So it's just kind of an interesting thing, and it makes sense because, like, water is H2O, right? Hydrogen and oxygen are both super flammable. When they're together, they make water. You can put water on a fire and put it out, right? But if you have H2O2, that's peroxide, right? So that would be like hydrogen peroxide, the stuff you put on your cuts that burns but cleans out the bad stuff, right? So totally different just by changing a little bit of the ingredients. All right, and bonds are what hold these things together. Okay, and that's what we're going to start looking at, is how these atoms actually bond together. And bond is just a word that means stick together, right? Like if you've ever heard of, like, using bond on furniture or whatever, it would just be a word for glue, right? So bond is just another word for sticking it together. Okay, so the properties of the compounds depend on what atoms are in them, right? So if you use different ingredients, you're gonna get something different. So it's like if you're making a cake. If you change the ingredients a little bit, you're gonna have a totally different cake. Like if you switched a cup of sugar for, a teaspoon of salt, and you put a cup of salt and a teaspoon of sugar, your cake is totally different. Same thing goes with these atoms forming these compounds. All right, so taking a look at these, we have water, we have salt. We can see they have no similar ingredients. They have very different properties, right? So when we talk about compounds, when we say, like, this is an example of ammonia, right? And ammonia is nitrogen with 3 hydrogens, so it's NH3. And you can kind of see how they're trying to visualize that. You have a nitrogen right here in the middle. You have some hydrogens around it, right? That's what that 3 means. It's right after the H, so it means that there are 3 H's. This right here is a good example of showing that there's a nitrogen connected to 3 H's, okay? And if you took a look at the periodic table, you would see nitrogen's in column 5, right? So if nitrogen is in column 5, that means it wants to gain 3 electrons. Gaining 3 electrons from hydrogen, boom, they can all share, and now they're happy. Okay, so then what it's saying right here is this 1-to-3 ratio. There's always going to be 1 nitrogen to 3 hydrogens, but that would be like a microscopic amount of ammonia. So if you have like a cup of ammonia that you were using to clean or something, that's going to be way more than just 1 nitrogen and 3 hydrogens. That would be, thousands and thousands of them, but the ratio is still the same. So there's going to be, for every 1 nitrogen, there's going to be 3 hydrogens. Okay? So we can write these chemical formulas like that. Like you have all heard of H2O. We talked about NaCl. You just saw ammonia as NH3. All these different things in the world have different chemical formulas. All right, so chemical bonds are the glue that hold them together, and they happen when the electrons interact. So we've talked about that. We've drawn models of that. We can see when the electrons interact, things happen. So we can have ions, and we've talked about ions when we've had a positive or negative atom. And when we have a positive and a negative, just like with the positive protons, negative electrons holding the atom together, we can have atoms be attracted to each other that same way. So let's say atom A gives an electron to atom B. Okay, well that means now that atom B has 1 extra negative charge, so its overall charge is going to be negative. Well, atom A gave a negative away because it gave an electron away, so now its overall charge is positive. Okay, and that's kind of what's being explained right here. Well, now those two atoms, we have a negative and a positive, now they're attracted to each other and they can bond. Okay, so that's one way that these things can bond. Kind of talked about this already. Ionic bonds form between nonmetal and metal atoms. This is not too important for our sake. It's just a little extra information. Talking about naming them, that's kind of interesting. So for this idea with ionic compounds, like you don't need to worry about this. I took a class, organic chemistry, where it's like all you do is name compounds. We don't need to worry about it. But kind of like when I said sodium chloride, right? That's table salt. That's kind of the way you name it. So like the first thing right here is Ba, is barium. And then they have barium iodine. So it'd be, you take it off and it would be barium iodide. Right? So kind of like sodium chloride, we have barium iodide. And again, you don't need to worry about that, but just information if you want. Covalent bonds are different because they're not, like, it's not when they give an electron to the other one. This one, they're just sharing electrons. I don't really need us necessarily, it's not one of our standards for you guys to be able to tell the difference. I just need us to be able to talk about how these bonds, they're just an interaction of electrons. But the difference would be that ionic bonds, one atom gives an electron to another atom, and in covalent bonds, they're sharing an electron. And this is all happening with the valence electrons, right? We've talked about that. It's the outermost electrons. And I told you guys how we're just going to say that all the outer ones have 8 for our understanding, because that's all we need to get to, and I kind of told you that's a lie. Well, this is kind of expanding on that. But for our sake, we only need to worry about getting to 8. All right, so let's kind of look at what happens at on the atomic level, and then we can kind of look on the bigger picture next week when we look at some chemical reactions. We're going to look at what's actually happening. So right here, this is the game you guys are going to play this week. Okay. And I'm looking right here, we have an NH3, which you guys learned is ammonia in this video, but you don't need to worry about what it's actually called. And we're showing that this arrow is saying that this is breaking down into nitrogen and hydrogen. Okay? And nitrogen and hydrogen are always usually bonded with themselves, right? So this is showing you that there's 2 nitrogens on this side, and there are 2 hydrogens on this side. And if we look over here, when this ammonia breaks down, we're showing that there's 1 nitrogen and there's 3 hydrogens over here. Okay, so if I go ahead and say there's 1 of everything, our goal is to balance this equation. Okay, so right here there's only 1 N. Over here there are 2 N's. If I add 1 more ammonia to this side, right now it says that 2 ammonia molecules, or 2 NH3s, are chemically reacting, and they're breaking down into 1 N2, which is 2 nitrogens, and 1 H2, which is 2 hydrogens. But we can see over here that now that I have 2 ammonias, there are 3 hydrogens on each, right? So that makes 6 total. So if I come over here, well, now 2, 4, 6. So I could look at this and say, well, if we had 2 molecules of ammonia, that would react and break down into 1 molecule of N2 and 3 molecules of H2. And that would be balanced because we see there are 2 nitrogens, 6 hydrogens, 6 hydrogens. Boom. You can check that. And good. All right, now let's look. If we had a CH2O, which would be a carbon, 2 hydrogens, and 1 oxygen, and this is reacting with a hydrogen that's bonded with itself, so an H2, that would react to form a CH3OH, which is a carbon bonded with 3 hydrogens, bonded with an oxygen, bonded with another hydrogen. And you might ask, why is that hydrogen not over here? Well, that's just how that chemical is arranged, so that's how we would write it. Okay, so you don't really need to worry too much about that. We're just focusing on being able to balance these things. So if I put 1 of each, well, this shows that 1 CH2O plus 1 H2 would make 1 CH3OH. Well, let's count and see. I have 1 C on this side. I have 1 C on this side. I have 1 O on this side. I have 1 O on this side. Okay? Actually, the O's technically would be the orange dots, but that's okay. If I look at the H's, I have 1, 2, 3, 4. If I look at the H's over here, I have 1, 2, 3, 4. Well, to me, that looks balanced already. Boom. That's an easy one. Let's do one more. If I had 1 H2 plus 1 F2, I make 1 HF. Now let's see. Would that work? I have 2 H's. I have 2 F's. I only have 1 H and 1 F. Well, let's add another one here. Now we have 2 H's, 2 F's, 2 H's, 2 F's. That balances. Now you might be asking why. Like, what does this matter? What are we talking about? Well, if we think back to the PowerPoint, when we were talking about the ammonia, right? And they said that they always have this ratio of 1 to 3. Well, if you wanted to make a bunch of ammonia, right, you would need to put in this certain amount of nitrogen and this certain amount of hydrogen, or else you would have a bunch of extras. And that's what this is showing, right? If I was going to make pH 3, or if it was even going to be happening naturally, because a lot of this does happen naturally. It's not all happening in a lab, right? It's happening around us. It happens in the earth. It happens in the air. This just happens with these specific ratios. So in order for this reaction to happen, we couldn't just have 1 molecule of P4 plus 1 molecule of H2, because those don't work for this reaction. There's not enough H2, and we have way too much P4. So could these react and make something else? Potentially. They might. But they wouldn't react to make this. So let's change it. We're going to need at least 4 P's, right? Because there's 4 P's here, so let's make it 4 P's here. And now if we do that, we have 3, 6, 9, and 12 H's. Well, over here I only have 2. So if I bump this up to 6, that would be 2, 4, 6, 8, 10, 12. So this is saying that if I have the ratio of 1 molecule of P4 with 6 molecules of H2, I would make 4 molecules of pH 3. All right? And I know that's a little bit strange. What are these molecules? What are those atoms? That's not totally important right now. Right? I want us to be able to think about how these atoms are actually connecting. And with the other videos, the other activities, we've kind of looked at some chemical reactions as well. Next week and the week after, that's going to really be our focus. We're going to look at chemical reactions and see, how do we know if a chemical reaction happened? If I mix 2 things together, what has to happen for me to know that there was actually a chemical reaction? Is it going to explode every time? Is it going to bubble? Is it going to make a gas? What's going to happen? Well, not always, right? Some chemical reactions might change colors. Some might get warm. Some might not do a whole lot at all. Okay, so we'll be moving into that next week. Let's check that work, make sure we got it right. We did. That's that. Hopefully this helps you with that game as well. So for those of you guys in class that say, I don't know how to do that game, I will say, you did not watch my video, did you? All right, get to work. Have a good day. See ya.